All right, so this is gonna be a short video going over some examples of writing out net ionic equations for these various acid-base reactions here. So let's take a look at this first one. Looks like HCl. HCl is one of our strong acids. And NaNO3, that does not look like a strong base I'm familiar with, so I'm going to assume that it is a weak base, and we'll take a look at how that works here in a moment. So we're going to put together our HCl aqueous and our NaNO2 aqueous there, and this one, I guess this one, since two compounds, we can kind of approach it like a double displacement reaction, actually. So we can have the sodium and the hydrogen switch places. So now the sodium is with the chloride. We know all alkali metal compounds are soluble, so that's AQ. And then the H is going to go with the NO2. Okay, and then let's go through and we're going to ionize the things. We're going to ionize, remember, two categories of things. We're going to ionize strong acids, and we are going to ionize aqueous ionic compounds. So HCl is a strong acid, so I'm going to split it apart into ions. NaNO3, it's aqueous, it's a soluble ionic compound. And then NaCl, it's a soluble ionic compound. And then HNO2, it's not ionic, and it's not a strong acid. Remember, HNO3 is a strong acid, HNO2 is not. So with the strong acids, there's only 6 there to memorize. So memorize the strong 6, and then if it's not one of those 6 strongs, you can assume that it's a weak acid. All right, so now I'm going to take a look at this. I see my spectator ions are sodium and chloride. So what's left behind is H+, and NO2 minus gives us HNO2. So this fits our pattern of strong acid plus weak base. And then the product of this reaction, notice how this is the conjugate acid of this weak base right here. So that's the conjugate acid. And the conjugate of a weak base is going to be a weak acid. So that means the resulting solution is going to be acidic. So it's going to have a pH of less than 7. All right, so let's take a look at this next one. We've got KOH, aqueous combined with HNO3, and HNO3 is one of our strong 6 acids. We got 2 compounds and do a little double displacement style here. So the H is going to go with the OH, and then the K is going to go with the NO3. And H with OH, hydrogen hydroxide, we more often write that as H2O. So that is water, liquid water here. Whenever you're writing the formulas of compounds, remember you always need to think about ion charges. So K is +1, nitrate's -1. So that's why it's just KNO3. We don't need any subscripts there. All right, now we're going to ionize stuff. So I'm going to ionize aqueous ionic compounds. So that's my KOH, and I'm going to ionize my strong acid. Cool. I'm not going to ionize water. Why? It doesn't fit under one of these 2 categories. So the only things you should ionize are these 2 types of substances, strong acids or aqueous ionics. If it's a liquid, a gas, or a solid, don't ionize it. And if it's aqueous but not a strong acid and not ionic, then don't ionize it. Okay, so here, this one I am going to ionize because it's aqueous and it's ionic. And then eliminate my spectators. Cool. So now I'm left with is H+ and OH- makes water. And for these reactions, if you're just asked to write the net ionic equation, you don't have to go through and show all of these steps. It's just really important you kind of conceptually understand where this is coming from, and you understand the ideas of which kind of substances will ionize in solution and which will not, because you might also be given a scenario maybe where it's like a visual showing a particle level diagram, and you want to be able to, recognize which substances should be ionized and which should not. So just FYI, you don't have to show all this work, but you do need to understand what is happening here. And so that's why I'm showing it for you. All right, let's look at the last example. We've got NaOH which is aqueous, combined with HCHO2 aqueous. Again, do a little double displacement, swap your H and your Na, and that gives you HOH, otherwise known as H2O. And then you're left with NaCHO2. I might not know what CHO2 is, but I know any alkali metal compound will be soluble. So I'm going to label that with an AQ. Ionize my sodium hydroxide because it's ionic and it's soluble. And then HCHO2, it's aqueous, but notice how it's not a strong acid. It's not one of the strong six I'm familiar with. And it's not ionic because there's no metal, non-metal. So this does not ionize. Okay, so this is an example of a weak acid. Weak acids you don't ionize them when you're writing out these equations. That's the thing that's, might be different from what you remember doing in earlier units here. So that's the new information we're seeing here with these weak acids. Okay, water's a liquid, so I don't ionize it. And then this, again, it's an ionic compound containing an alkali metal, so it is going to be soluble, so it's going to ionize. So notice in this example, we only have one spectator. So what we're left with is hydroxide plus HCHO2 makes H2O and CHO2 minus. Sorry, I kind of ran a room here. I just realized I forgot to answer that second part of the question earlier, but this one is, notice that we're producing CHO2, which is the conjugate base of a weak acid. So this is a weak acid. This is its conjugate base. So the conjugate of a weak acid is going to be a weak base. So this solution is going to be basic, which means we have a pH greater than 7. All right, and let's go back and look at question 2, because I accidentally skipped this one. The product of this reaction is water, so this one is going to be neutral. So going to summarize kind of the key pattern here. If you've got a strong acid, this is an example of a strong acid plus a strong base, the pH of the resulting solution is neutral, because you're just making water, and that's it. In this example, when you have a strong acid plus a weak base, you end up with a solution, a product that's acidic, because it's the conjugate acid of that weak base. And then in this example on the bottom, with number 3, this is a strong base plus a weak acid, and the product of this reaction is going to be water and the conjugate base. So in this example, the product is going to be basic. So the pH of your products is going to depend upon what you're combining together here.